Okay, so after we open up Ansys Fluent, we want to go ahead and drag the Fluent module onto the project schematic. We're going to go ahead and rename that to flow over a cylinder because that's the problem we're tackling today. After you do that, you want to just click on Geometry once. A tab will open on the right. You want to change the analysis type from 3D to 2D analysis. After that, just double click on Geometry. It will take a minute to load up. We'll just wait for it right here. So once that's open, you want to click on the Z-axis on the bottom right to get a top-down view. After that, you're going to go to Geometry on the left-hand side. Make sure the set grid. Make sure the show in 2D and snap options are both ticked. Anything under that, major grid spacing, snap per minor, all that, set that to 1. After that, we want to go ahead and go to Draw. Draw a rectangle on the grid. Dimensions don't matter right now because we're going to change that from Dimensions tab. Let's start by changing the vertical dimensions. Select the top part of the rectangle to change first. We're going to set that to 7.5 meters to start off. We're going to do the same for the bottom half, also 7.5 meters from the x-axis. Now we're going to go ahead and start changing the horizontal dimensions of the rectangle. We'll start with the left half. Just click on horizontal dimensions, click on the left half, and select the y-axis as your reference. We're going to set that to 16 meters. As for the right hand side, we're going to set that to 14 meters. Once that's done, we're going to go back to the draw option and we're going to select circle because we want to represent our cylinder. And we're going to draw the circle at the origin. Again, the dimensions of it don't matter right now because we're going to go ahead and change that once we put down a circle. Go to the Dimensions tab and set diameter, and set the diameter of your cylinder to 1 meter. Once that's done, you want to go to Modeling. You set the XY plane. Select sketch number 1. Now go to the toolbar on the top. Once you do that, see, we're going to do the modeling. We're going to go to the XY plane. We're going to select sketch number 1. And now we're going to go to the toolbar on top. Go to Concept. We'll see that in a minute here. Okay, once you go to Concept, you want to select Surfaces from Sketches. You'll get an option next to Base Objects to apply. Go ahead and click on Apply. After that, you want to click on Generate. Now you start seeing the graph changing, the grid changing. Once you click on the surface you have, you're going to have an option to change the fluid or solid, and you're going to set that to fluid. After that, go ahead and save your progress so far because that will conclude the first part, the geometry. We're done with the geometry for now. And yes, go ahead and save it before we move on to meshing. Once the geometry aspect is done, we want to go back to the product schematic and double click on mesh to open up the mesh module. It's going to take a bit of time. After it's open, you want to go to the left hand side, as seen here in the video. Go to geometry, go to surface body, and change the thickness from 1 meter to 0 meters. Make sure your units are in metric. Go to mesh, go to generate mode. After that, you'll see your mesh represented. Go ahead and right click on mesh again, insert method. Go to geometry and click on apply. Change the method to triangles on the bottom left. Select the body and insert sizing. After that, go ahead and use the edge selector on the toolbar on top to select the edges of your outline. Select the cylinder outline, the circle outline, and go to geometry and click on generate. Go ahead and change the element size to 0.025. Now we're going to right click on mesh again and click on generate. Right click again on mesh and click on inflation. Go to geometry, click on apply. Go to boundary, select with the edge selector the edge of the cylinder, which would be a circle. Go to boundary and click on apply. Now just select your area and change. You want to go ahead and change the inflation options to first layer thickness. Change the first layer height to 0.025. Change the maximum layers to 40, as you will see here in the video in a minute. And change the growth rate to 2.5. Click on update on the top left hand side. Now you want to go ahead and click on mesh again, go to sizing, and change the maximum face size to 0.3. After that, we're just going to go ahead and click on update. Now we need to define the boundaries of the domain. Now we do that by again select your edge selector. Select both the horizontal edges of your rectangle, the top one and the left one, using control and clicking on the respective edges. You want to go ahead and right click and create named selection, having selected both those horizontal edges of the rectangle. Name these a wall, because these will be the walls for our analysis. Repeat the steps for the left hand vertical edge and simply name it inlet. Do the same for the outlet, naming it outlet. Do the same for the cylinder as well, and name that the cylinder. Right click on the edge of the circle, create name selection, and name that cylinder. Click on OK. Now simply update, and we'll go back to the project schematic and click on update.
We launched the setup, so we're going to choose double precision, parallel, and we're going to change the processor to 4 processors so that it can speed up the process, and we're going to choose 1 GPU. Click OK, and it will take some time to launch the setup. Now on Fluent Answers, we're going to change the time. We're just going to give it some time to start up. And we're going to change the time to transient. Then we're going to go to material. We're going to select air. It has the following density and viscosity. Click close. And then we're going to go to the boundary conditions. And we're going to change the boundary conditions for the inlet velocity. We're going to change the velocity to 80 meters per second. Click OK. And then we're going to go to reference values. And we're going to compute it from the inlet. So then for the solution method, we're going to select second order implicit. And then we're going to go to monitors, and we're going to add lift and drag coefficients. So we're going to go to create, drag, print to console, plot, axes, Why? Remove the auto range, and because we know the range is from 1.2 till 2. Apply, close, okay. We're gonna choose the cylinder. Then we're gonna create a lift, print to console, plot same procedure, cylinder, axes, Y, and remove the auto range, because the range is from minus 0.25 till 2.5, 0.25. Press OK, and then we're gonna go to solution initialization. We're gonna select hybrid initialization and click on initialize. So there we're gonna go to calculation activities, change the time step to 1 so we can create an animation, and then we're gonna go to run calculation and we're gonna change the time step to 0.01 and the number of steps to 250. Then we're gonna go to max iteration and change it to 50 iterations. Then we're gonna click calculate, and this will take some time, so we'll be cutting the video and show you the results. And these are our results. This is the drag coefficient and this is the lift coefficient. So then we're gonna go to results, double click on results. And we're just gonna create some contours. We press on this contour. I've already added some contours, and this is the streamline contour, as you can see, and this is the velocity contour. The other contour is the pressure contour, and from the contour details we can change the variable, change any variable we want to examine. We can change the number of contours. When changing the number of contours, it will give you a better quality for higher number of contours, as you can see. And that was for the velocity in the Y direction. This is for the velocity in the X direction. You can choose any number of contours you like. As I said, more number of contours means better quality. However, I'm going to change it to 20 so we can put an animation. We can click on animation, time step animation, and we should first go to advanced frame selection and click save, and then we're gonna just click play. And see, now it's loading the frames. It's playing it frame by frame depending on the time step. As you can see, it's loading the time step down there, and it's saving as it's displaying the animation in the workspace. And that will be it for our project for the intermediate fluid mechanics. Thank you all for listening.